Hello, everyone, and welcome to Web Development with ASP.NET, episode number 5, with your host, Mr. Nelson LeKay. Nelson.
Hey.
Hey. And also joining us, we've got Mr. Zach Parrish.
Good evening.
And myself, Jason Busby. And we're going to be picking up here in episode 5 where we left off with episode 4, discussing NHibernate and also taking a brief look a bit more at the NHibernate profiler. So, Nelson, if you'd like to tell these good folks what it is we'll be looking at tonight.
Well, in the last episode, we talked about setting up NHibernate, mapping your objects, and initializing the session factory, and basically all the stuff you see here, in addition to inserting objects and updating them and deleting them. But we didn't really talk about querying objects, which is generally pretty important when you're working with databases. You need to get the data back out somehow.
Right.
And the reason we didn't go over it in the last episode is that kind of the method that we're going to be using to query NHibernate, and there's a few other methods that I'll briefly cover in a second here, but the method that we're using is going to be the LINQ to NHibernate provider, which is new, or rather built in as of NHibernate 3. Previously it was an extension made by a third party, but now it's first party, great support. And when you use LINQ to query anything other than objects with linked objects, there's a lot of stuff you need to take into account, and we're going to cover kind of the requisite knowledge in order to make sure you don't shoot yourself in the foot as you query with LINQ to NHibernate, I guess I could call it.
Okay.
So we'll be talking about expressions and the IQueryable interface and how it relates to NHibernate in your entities.
Okay.
Sounds good.
Yeah, but the first thing, like I said, there's 3 ways to... Well,
an internal battle going on.
Yeah, I heard it.
There's 4 ways to query objects with NHibernate. You can use direct SQL, and that is where we're not going to talk about this too much, but essentially you go into your mappings and you add a SQL query mapping, and you give it a name, and then you type in your query, say what entities it returns and all that stuff. That's the simplest way to query NHibernate if you have a SQL background, but we're not going to be using that at all. I'm not going to say at all, but we'll try to avoid that because, well, we're using an ORM, and otherwise, if we wanted to use SQL, we wouldn't be using NHibernate. The second way to do it is with HQL, which is a SQL-like query language built specifically for Hibernate and ported to NHibernate as part of NHibernate's creation. And it's really similar to SQL. It has some differences where generally the language is more object-oriented, and you use just normal strings to communicate with that. And people decided that was kind of nasty. Using magic strings isn't a whole lot better than SQL. So they invented the criteria. Criteria API, where you build these criteria objects, and they're strongly typed objects, and huge interface. It's pretty straightforward, completely strongly typed, and use these criteria objects to put together a query that would query NHibernate. And that's what was done before the LINQ to, well, that was what was primarily done before the LINQ to NHibernate provider was created and then baked into the core. So then the last method, the method that we're going to go over, is the LINQ to NHibernate method, which uses the standard IQueryable interface, which we'll talk about in a second. And it implements all of the LINQ operators, and it does so in a pretty good way. I mean, for first-party support, there's no reason not to use it. And it's going to look pretty much exactly like your LINQ to objects, but like I said, there's a few things you need to understand about how that works.
Okay.
Wow.
So where do you want to start?
Well, do you have any quick questions? But because we're not going to be talking about HQL, SQL, or the iCriteria interface thing at all. But do you have any questions about those, Jason or Zach?
No, actually, I would be more interested in the LINQ to NHibernate anyways.
Yeah. Alrighty. So I'm going to go ahead and actually launch a new project, and we're going to come back to this project once we start working with NHibernate again. And the reason is like I said, there's some requisite knowledge to work with any LINQ provider that isn't properties dialog. Any link to database, link to SQL, link to entities, link to NHibernate, link to SQL, blink to insert ORM here that provides link provider. And what they do is they use something called expressions. Expressions are really cool, but they're pretty weird. It's a really abstract sort of thing. I'm going to go ahead and define a really basic expression here. Actually, above it, I'm going to do another method. That's something that everyone's going to be familiar with if they've seen any of these videos before. Yeah, it's keyword stuff. So everybody knows how this works. You feel pretty comfortable with that so far,
Sure.
Zach?
Sure. I mean, it's going to write hey and wait for a key.
Yep. And we're passing in a lambda, and it's going into this delegate, and then it's being invoked. Expressions, to use an expression, well, here we go, represents a strongly typed lambda expression as a data structure in the form of an expression tree. To use an expression, we simply wrap a delegate, so any delegate, so this is action, we could wrap in an action that takes an integer, for example. Or we could wrap, any other delegate type, a custom defined delegate or a delegate provided by the BCL. But we're just going to use action right there because it's the simplest delegate, obviously. It takes no parameters and returns nothing. So all we do is we have an expression, and then we have an expression of type delegate, and then we have a parameter. And when I introspect this object, we see a lot of weird stuff in it. Probably the most important, we have... I'm going to go ahead and actually debug this and introspect this in the debugger. And then I'm just going to nuke the A, so now we're calling method with our expression, and then I set a little breakpoint right there so we can actually look at what this expression object contains at runtime. So you see that we have a bunch of stuff.
Mm-hmm.
We have a return type void, because this lambda returns a void, and like the documentation said, this expression object is a strongly typed representation of this code. It's really meta. So we have this this expression that returns a void and takes 0 parameters and has a body, and this body has a method call to write line, and then also has a list of arguments containing the arguments that we have. We can make this more complex, and I know this probably isn't making sense to anybody right now.
Yeah,
we can
pretty much.
We can make this more complex by having a delegate that takes 2 integers, and we can do like x, y. Then we can do like a string.format or something. And so if this didn't take an expression, this would be pretty straightforward. We're passing in this lambda, and this lambda is a lambda that takes 2 parameters and writes them out to the console.
Yeah.
If we debug it, we'll see that this contains, well, like the documentation, this contains a strongly typed representation of the code. We can actually break down every single piece of code that went to this lambda by introspecting this expression type. So you see that this expression type takes 2 parameters, x and y.
Mm-hmm.
It has a body, and the body calls a method, system.writeLine, and has arguments. And the argument is another method call to string.format, and you can just keep on going and going and going until you hit, the end of it, which is the parameters that are passed into string.format. And it's really difficult making this make sense because it's so meta.
I think part of it is that you haven't really defined what an expression is in a way that I can follow you.
Imagine
you're showing kind of what's going on under the hood when you invoke an expression, and I'm cool with that. I mean, to a certain degree, insofar as I can be. But because we don't have a definition to work from, I'm not really sure in what direction I should be following you.
Okay, remember when a long time ago, you said something that I thought was really cool. You said that, that first, you learned how to store values in variables, and then you learned how to store instantiated classes or objects in variables. Then you learned how to store methods in variables. This is storing code in variables.
Okay.
This code right here is being stored into a variable. Not this method. This isn't a method because it's being assigned to an expression. Right. This is actual code that's being assigned to this expression type. And we can use other code to introspect this expression and actually read out whatever code.
Well, you could do a console.writeLine and do expression to string. That's kind of cool.
Yeah, it is.
Yeah.
Writes it all out for you.
So you see that they've stuff and things.
Yeah, what was the for?
No, it's just it still is. It's a really meta concept where we're not storing a method in this delegate anymore. It's not a delegate; it's an expression, and we're storing code in it, which is a really powerful concept if you think about it, because it allows us to do a lot of weird meta-programming stuff. Zach?
So basically what I'm seeing is that whatever we feed in through that Lambda is basically just going to get written out as a string?
That's the output of this program, yes.
Yeah.
But how it works is that this expression is being passed into this variable, and this variable then stores the actual code of this expression.
Okay.
So it stores the actual the code. It doesn't store instructions like a method.
I mean, I can prove how it's doing code. I mean, you could take this and say something like var my equals. You can now compile that code, and then with that go ahead and invoke it from right there. So I'll check this out.
And I'm actually going to do I'm going to not use implicit typing here. I'm going to just do that.
Okay.
Oh, look at this! All the beating on implicit typing.
I know, man. He's just like harps on it
and we're
so
local
much.
Inside a method.
I wasn't given the opportunity, but if you had asked, I would have said it's going to report back 10-10.
My implicit typing would have worked just fine.
I'm sure.
Oh, no, it would have, and I would have used that in real code. I just wanted to outline the fact that this expression.compile actually takes the code that's stored in this expression and turns it into the delegate type that was passed in as its type parameter.
Right.
And then implicit typing works just as you would expect it to.
Yeah.
And the way this works is actually really interesting. The BCL or base class library it exposes the expression library, and the expression library contains every single building block that you need in order to represent code in code.
Okay, so I mean, are we running into like a situation where this gets like pre-compiled before your program actually compiles?
Well, yes. Well, I kind of wanted to show this first, though.
Okay, I don't mean to get ahead of you, but like when you throw up like the compile command like that, I mean it stands to reason that you have to compile all of that code that you fed into your expression so that you can use that on the next line.
Yes.
Okay.
But remember, generally people don't use .compile very often.
Okay.
I wouldn't say simply because
cool,
in cases where expressions, it is really cool. In cases where expressions are used, generally the benefit is to introspect the code, not actually invoke it, and we'll get into that in a second. But the expression library, this is, like I said, provided by the BCL or base class library. It contains all of the building blocks that we need to represent code in a strongly typed way. You'll see that we have if statements, else statements, for each statements, or probably not for each statements, but we'll have a while statement, or loop. Yeah, there we go. It's called a loop.
I mean, does this boil down to a nice, convenient way to reuse code? Why take a batch of code and plug it into something like a variable? Why do this? What's the reason?
It's the building blocks of LINQ to NHibernate, or LINQ to SQL, or LINQ to XML. And I'm actually going to answer that question right after we get into Reflector.
Okay.
Because the one last thing you have to understand is how does the C# compiler actually do this? Because this is not a feature of the .NET framework. This is a feature of the
You know, at the beginning of this video,
compiler.
he didn't say anything about using Reflector. I mean, I'm just saying.
Well, I mean, I'm sure Jason knew that I was going to use Reflector.
But
I say it's
a bonus.
It's a given.
Okay. Taken for granted.
I'm actually going to do one expression dot. I've only used this library in one really, really weird instance. No, this is going to get too complicated. Because then I'll have to pull out reflection reflection. But let's pull up Reflector and see what the C# compiler actually does to this code when it's passed into this method.
Yeah.
Because that's important.
Mm-hmm.
And then we'll show the IQueryable interface, which is the building blocks, or which is basically how you query things.
So you're showing this thing with expressions because that's how LINQ to and Hibernate is going to work?
Yes.
Is that basically what it's leveraging on the inside?
Yes.
Okay.
And it's important to know that expressions are not real code, and we'll show why that's important
Yeah, you
soon.
just blew my mind with that statement.
I don't know what's going on right now. What'd you do to your Reflector, Jason?
I haven't touched it.
Well, apparently you need to choose an item in the assembly browser to view decompiled source code.
Well, apparently there is no assembly browser.
I was just trying to help.
This is not the appropriate time to mail feedback to them.
What? What's going on? How could you not show the most important aspect of... That's just poor UI design.
Rawr.
You get them, Nelson.
Well, allowing you to collapse... There we go. That's what we wanted. I don't know why it didn't appear before. But anyway, console application... Yeah, go away. Console application 9 is what we're in, so we'll look at that. And this is actually going to be kind of difficult to show because Reflector is really smart. Oh, there we go. If you were in .NET 4, Reflector is really smart, and it sees that you're doing this, and then it just shows you... We already talked about how it does that. Mm-hmm. So we need to go into a .NET version or a C# version that didn't actually support this to see what it's actually doing.
See how it gets kind of broken down?
Yep. Actually, I'm going to one-up this. Check this out.
He almost said you want to see something cool, which is usually the harbinger of something terrible.
Terrible.
So, yeah, might put a comma in there. And there we go.
Okay, so we have two method calls, one to method A and one to method. Method takes an expression of type action of type into comma, and method A takes just an action.
Okay.
And we'll see the difference once it refreshes. Okay, so you see for method A, the method that just takes a normal lambda, or takes a normal delegate.
Yeah.
We create an anonymous delegate. I wonder what this looks like in .NET 1 that didn't even have anonymous delegates. Yeah, just a bunch of weird stuff. So this just takes a anonymous delegate. C# 2 didn't have lambdas. You actually had to write it out like that, which is ugly. But the one above it, because it takes an expression, the C# compiler picks up on that and does this magic, where it turns all of that code into .expression calls like that. So
yeah,
you see that's actually...
stuff.
Turns it into a data structure.
Yeah. So you see that expression.call, method of console.write, method of is probably some weird thing somewhere.
So, basically it's a tree-like data structure, hence the name expression trees.
Yep. And it's really, really cool stuff, really powerful stuff that the C# compiler is doing for us. I just want to point out something real fast here that we'll get into, definitely, that will literally
blow your mind?
It won't blow your mind, but it'll impact our ability to use certain things. So now we have a method, a real normal method, that does the exact same thing as our other lambda, but we're just going to say that. We're just going to call that method. So what does the C# compiler do now? Does it actually go into this method and turn this into an expression tree? And that's an important question to ask yourself when you're working with libraries that depend on expressions, because as you'll see in a second, all it's going to do is create an expression tree that just invokes this. So remember that the expressions generated are the literal of what's in this lambda. If you delegate this off into a method, the C# compiler is not going to turn this into an expression tree.
Okay, it's just going to call that method.
Right. Okay, so those are expressions. Do you have any more questions other than why would you ever need this?
That's my biggest question right now. I mean, I see really generically what these are.
I know Nelson said not often, but I'm a big fan of saying that the fact that you can compile and execute code. I mean, while running,
well, that blows my mind.
This
That's
allows
like
this allows basically dynamic modification of executable code.
Well, you can even build these expression trees dynamically, then compile them, which is also cool.
Absolutely. So while you're inside your already compiled application that's running, so the fact that you can start building code in a program dynamically, compile and execute, is
it just seems insanely powerful.
Exactly.
Right. Okay, so IQueryables.
So I can sum up expressions in my head. If I'm looking for a really general definition just to keep in the back of my head at all times, it's a way to store a block of code in a variable-like manner.
Yes.
Okay.
It just to extend on that thing that you said a while ago.
Yes.
We're now storing code in variables.
I mean, it's safe for me to think of them that way.
Yes, it is. So now we have iQueryables, and unfortunately we don't have an iQueryable implementation laying around here, but we can
make
do
one.
This. Well, it's actually kind of a nasty interface.
All right, fine.
You have to worry about the query providers, and it's actually not a pleasant thing to implement. See, an iQueryable interface. Actually, we want this guy. We want to pick on the generic type, or that's an I-ordered queryable. What am I doing? That guy. Okay, so the iQueryable interface, all it does is, well, the generic type doesn't actually have any of its own members, but it implements IEnumerable and IEnumerable of type whatever you passed in, and the iQueryable interface, which has an element type expression and provider, which are kind of boilerplate stuff we don't need to worry about, because these have to do with how the iQueryables are used. And so, like IEnumerable, iQueryable implements IEnumerable, so every single iQueryable that you have is an IEnumerable.
Yeah.
We can go ahead and look at. We can go ahead and just kind of look at what the difference is when we work with one by doing this. Let's use the as queryable. This actually isn't going to do anything because we're in link to objects land. This method, but it does have significance when we're working with Hibernate.
When you say link to objects land, am I thinking just regular link?
Yeah.
I mean, like when I put like using link up in the top area, that's link to objects land.
What are you using these extension methods with when you're using it with lists and
all right?
Just
when he says a phrase like link to objects land, I just want to make sure I totally understand what he means by that.
Link to objects is what we've been discussing up till now.
That's what I thought. Okay.
But you see that test, and I'm actually going to do this again, just to make it more explicit. This is the actual type of it. It's an iQueryable of type int, because it's an array of integers with the as queryable extension method applied to it. And so if we do test dot, we'll see a bunch of familiar stuff. You know?
Yeah.
We see where, and we see select, and we see group by and join, and max, and all that stuff. But if we actually click into, let's pick on select or where, because it's arguably the simplest one, you'll see something strange. Maybe not. Maybe I have to be in. Oh, there we go. So you'll see something strange about this this signature. Do you notice anything strange, Zach?
I don't spend a lot of time staring at signatures, so no, not off the top of my head.
Okay. The normal IEnumerable. The normal IEnumerable extension methods, which look deceptively similar to the iQueryable ones, if you look closely at their signature, so I'll just pick on while again.
It was where, wasn't it?
Where, yeah. I don't know where while came from. Just think about loops. Okay, so if you look at where, and you note its signature, it's an IEnumerable of type int dot where func int bool. So it's it's taking in a delegate.
Yeah.
If we look at
Now
the IQueryable type,
it's an IQueryable, but
It's an expression.
expression. Okay, gotcha.
right. So the IQueryable interface implements all the same, well, rather I should say the interface or the extension methods have been pretty much copied over verbatim from LINQ to objects land, but they've been applied to IEnumerable, and every single delegate is replaced with an expression.
Okay.
So all these things take expressions. And right now, if I were to do this, I'm actually going to do 3 and 3.
Yeah.
If I were to do this and I were to console.writeLine test1.distinct or accept set test.any. This is a trick that you'll see me use a lot. Just to read it out real fast. Accept returns the difference between these two IEnumerables. So this is going to be the difference. So if this had an extra element, then extra element would be in this IEnumerable,
right,
and then any returns if anything's there. So this is basically saying if this is true, then these two IEnumerables are the same. Otherwise, if it's false, they're not the same.
Okay.
And we can use that to prove that it's true in this case, because we're using the link to objects as queryable, which is really just a dummy wrapper over the as queryable stuff. But when we get our IQueryables from other sources that have the chance to actually implement their own IQueryable interface, they can do whatever they want. And that's where the power of of LINQ comes in. Or I don't know how to distinguish link to objects from link to everything else. But what I'm saying is that how they do all their stuff is by returning a different concrete class right here that has the database logic or the XPath logic or whatever you're querying logic. And then it does its own thing when you do .where. And remember that an expression is a variable of code. So this .where doesn't even need to execute this code. In this case, it does, but we'll see in a second that that's not true all the time.
Yeah,
so
you blew my mind with that one.
Anything else, Jason, that I should?
No, that's fine.
That's fine. You sound very happy about it.
No. Please understand, and everyone out there that's listening, I'm going off of pretty much no sleep, so I'm very tired.
Okay.
Okay, so let's introduce a few people here.
So the big thing I take from the last thing is that a standard IEnumerable is just going to use a function to work through its result, where an IQueryable is going to use an expression.
Well, you just saw func, but I mean it's using a delegate.
Right.
Where the other one is going to take code in.
Yeah.
Through the form of an expression tree.
Okay.
Yep. So here is our database, and it's full of the same data, apparently, between these two tables. There we go. What? Yeah, that's it. So here's our database, and it's full of stuff that we want to get out of it. So to go ahead and start using the link to...
For the record, you just jumped back to the previous project that we set up in the last video.
Console application 8.
Yes, on purpose.
Yeah, I know. Just make sure everybody noticed the switch, just in case.
Okay. So now we're going to query out this stuff from things.
So concise.
Now there's an extension method built on the session. So remember that this isn't, if you just do a little thing, you're going to see there's only a query over, which actually uses the, oh, maybe that does do the thing. I never looked at that guy before. But anyway, you want to use the query guy, which is an extension method which is provided by NHibernate.LINQ.
Okay.
And a quick note, before LINQ to Hibernate was built in as a version 3. If you're on version 2 for whatever reason, or you have experience with version 2, the equivalent method is called session.link, but they changed it to query. So just a heads up. So query is a generic method, and the type that query wants you to pass in is going to be the type of the entity that we are going to be querying over. And in this case, we're going to be querying over people. So we're going to pass in our person, and we're going to get our appropriate using statement. And we're going to close that, and then just do that. And you'll notice that the return of this method is an IQueryable of type person corresponding to the generic type we passed in. So if we were querying over person address, this would be returning an IQueryable of person address.
Okay.
So remember that this is an IQueryable. So if we do dot, we'll get all our awesome... no, we won't. If we do query dot, we'll get all our awesome link stuff.
Mm-hmm.
But remember that this is an IQueryable, so they all take expressions. So I'm just going to do a where, and then I'm going to pass in a really simple delegate. Person name contains, or name dot. First name contains. Actually, I'm not going to use contains yet. And then it's going to contain something.
You can do Zach, you can do Nelson.
Well, I forgot who we put in this database.
I saw you and me in there a second ago.
Yes. So we'll do first name equals Nelson.
The casing matter?
That's a good question. That I'll talk about in a sec.
Instead of just answering me? Sorry, I couldn't help myself.
I don't know, let's just show the age. And that's also, actually, let's go ahead and do a name and then an age. Let's break this out a little bit on this tiny resolution.
Yay. First name, last name, age. I see what you're doing.
Okay, so if we run this,
anywhere where you had an entry that had a first name of Nelson, you should get their first name, last name, and their age. But you're not waiting for a read key, so it blinks away as soon as it's done.
I hit a key, actually, on accident. There we go. So yeah, and that corresponds obviously to our data in our database.
I like this. I like this whole just plug a Lambda in for what it is you want to see. That's pretty fancy.
Well, it is really fancy, and it's really simple. And you might be asking, well, why didn't you talk about this in the previous video?
Why didn't you talk about this in the previous video?
Because if you didn't understand expressions, or at least have a cursory overview of expressions, you would run into a lot of pitfalls. And the first question that you asked is it case sensitive?
Yes.
You want me to blow your mind?
Oh god, brace yourself, everyone. Usually that means he's about to blow something up.
There are no people. So what's going on? That to list somehow made that case sensitive? Oh. Does that make any sense?
No, it really doesn't.
Okay. And the reason why that doesn't make any sense is because this where is being operated on our IQueryable and it's passing this expression. So LINQ to and Hibernate is introspecting this source code that is being provided by the C# compiler as a form of as an expression tree object graph. And it's turning the source code into SQL.
Mm-hmm.
Which it's really cool. It's seeing that we're accessing the first name. It's seeing that we're applying a equality operator, and then it's seeing that we're comparing it to a string literal.
Yeah.
And the interesting thing about it is what SQL is generated, and we can see that right here. We can't see that right there. We will be able to see it right there in a second. After I run it again with that. That was the to-list version.
Yeah.
This is the non-to-list version. So we'll see it right here. That this is the SQL. This is in Hibernate Profiler, by the way. We finally got it, or Jason finally got it working by setting copy local to true on the MySQL.data assembly. And if anybody is doing MySQL stuff, to do that, just right-click on the assembly, go to Properties, set copy local to true.
Do-do-do. So
I don't know.
needed to
That
find
shouldn't matter because MySQL.data is registered in the GAC, meaning the NHibernate profiler should have access to it, but it doesn't. So, stuff and things. We have this SQL that is generated based off of the expression that the link to an Hibernate implementation parsed out.
Yeah.
And that's why this isn't case sensitive, because it's creating the SQL. And in this particular instance, we're not using a case-sensitive coalition, meaning that this SQL isn't case-sensitive.
I mean, yeah, are you basically taking the long way of saying that it's not case-sensitive because this version of SQL is not case-sensitive?
The setting on this particular table.
We're not telling it to be case-sensitive.
Right, but well, the important thing to know is that this is SQL that's being generated.
Yeah.
By this expression.
Right.
So this expression follows the rules of SQL.
Okay.
Or of the SQL the SQL engine that we're working with.
I'm with you.
Mouse. Zach, talk.
I'm just not really sure.
I just see that the weather's pretty good.
The weather is pretty good.
I have a feeling that Nelson's mouse just went out again.
I think it did. I'm
so.
telling you.
And it's back, and I think that's enough talking for now.
Okay, so.
But basically, that where right now, what's he getting back?
He should be getting back the... Well,
Right there.
okay, hang on. We're getting back any result where the first name
Oh, no,
in the database...
No, I'm sorry.
Okay.
The type that we're getting back? If you move your mouse back over where, Nelson? Thanks, sir.
That's cheating.
I know, but it just gets Zach more comfortable with looking at this.
Oh, I figured we were getting back a person, but I thought it was a trick question.
No, it wasn't a trick question. We're getting back an IQueryable.
Oh, okay.
Now, go ahead and put the to list in there. And then when you put to list in there, and go ahead and run it again.
We're getting back an IEnumerable.
And then, very good.
Was that case sensitivity like just a mere compatibility issue? From going from an IEnumerable to an IQueryable?
Well,
see...
Go ahead, Nelson.
String objects, when you compare them in C# or in .NET land, are all case sensitive.
Okay. It's the SQL that isn't case sensitive. Yeah?
Right. So that's not case sensitive, or that is case sensitive. SQL itself is not case sensitive. Right. So when this is translated into SQL, it translates into SQL that isn't case sensitive, or depending on what SQL engine we're hitting. When we do the to list, what's happening is this.
Well, the final output's going to an IEnumerable, which is case sensitive.
Right. We're selecting every person.
Okay.
Then we're dumping it into a list object, and then we're using the link to objects.where on this. And so this link to objects.where has takes a func of type person, bool.
Now that's interesting. So we basically just switched out of link to objects, or out of link to in Hibernate link land back over to link to objects land. So it's actually a different implementation altogether.
Exactly.
Cool.
So that's really, 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 really important to know is when you're working on an IQueryable and a IEnumerable. And this is something that I see a lot of times. I'm just going to throw this out there. Zao. Okay, so we have our query people, and our query people takes an IEnumerable of person, and it returns every person that has a first name of Zach.
But if this is an IEnumerable that is not getting sent back to SQL, it should be case sensitive, yeah?
Yes. So when we do query people, and then we're just going to pass in this IQueryable, it's being implicitly converted into... Actually, this particular instance behind the scenes is a little bit more complex.
Okay.
What's happening is we're right here, because this is taking an IEnumerable person, this is being implicitly cast into an IEnumerable. So it's not like a toList, which actually transforms it into a list. This just casts it into an IEnumerable people. It's still the same object when it reaches here. When we do the .where, however, this is the important part, the .where is going to be on whatever type that this is. So the .where is going to happen on the IEnumerable, which is going to be the link to objects method. And as we saw in the previous, or 2 videos ago in the Nelson's Corner, the link to objects .where is implemented with the for each.
Mm-hmm.
And inside that for each, it'll actually execute the SQL against the database and come back into link to objects land. So if we wanted to make this better, we could do that. So now the .where is going to be on the IQueryable .where, which is going to actually invoke the SQL that NHibernate is going to generate for us. Does that make sense?
Pretty much.
So basically, we've got 2 different where methods that are going to be called. One where method using link to objects is going to be looking for regular equality between strings, where the other where
is actually going to execute a SQL query.
Comes up, generates SQL, and then executes the SQL, which then runs by the regular rules of a SQL query against a database.
Which is why that other link, like the NHibernate style of link, uses expressions.
Yes, because it actually has to take your code and transform it into SQL. And you'll notice this. Like, how many times do you think this is going to hit the database, Zach?
Yeah. I have no idea how many times it's going to hit the database.
Well, we can find out really quickly by opening up Jason's taskbar. This guy, 2 times.
Okay.
And same query twice.
Mm-hmm. I think you might have asked that in the previous video. Go ahead, please. Yeah. But I was just saying, I think you asked me that in the previous video, and I didn't know that either. Anyway, please continue.
Did we talk about querying in the previous video at all? I don't know. Anyway, how many times do you think it's going to hit the database now?
Well, I mean, I think maybe you just added 1 more. So let's just say 3 now. And it's just a guess, because I really don't know. I don't know enough of what I'm looking at to be able to give you an educated answer. I'm just throwing rocks in the dark.
We'll get the same results.
Okay.
But only once.
Only once.
And check this out. We can look at the stack trace, which is one of my favorite features of an Hibernate profile. I actually really like this program a lot. As much as I hate SQL, this program makes it bearable. We'll see that this query is being executed by this statement. And actually, I'm going to close this entire file, because Control-W doesn't close files. And then just double-click, and bam.
Nice.
Really nice feature. It finds whatever, I don't know how it works, finds the Visual Studio process and tells it to open this file and go to this line.
Do you hear that little dig about the Control-W setting on your computer?
Yeah.
I'm just making sure you caught that.
Got it. But yeah, basically right here, he's hit the database and put it all back into an IEnumerable. So now it's into a list.
Okay.
So as we execute the 2 for eaches,
that makes sense.
We're not having to hit the database. We only hit it the one time.
Right. We pulled it out when we defined people, and we don't have to go back for it again.
Yeah, because now people is an IEnumerable, and we're done with the database.
Okay,
work.
that makes sense.
Okay, next thing is, remember when we talked about how the C# compiler doesn't seek into your methods that you have and then try to pull out their code and generate the expressions? It literally puts in whatever's here as the expression.
Mm-hmm.
Well, remember that link to and Hibernate needs to understand the code, the expression tree that's being passed in. If it doesn't understand the expression tree that's being passed in, it won't understand how to work. So we'll have this, which it understands because it knows how to compare a string to a string literal. But if we had something like...
Basically, if you made a method and then just punch that method down there into your expression?
Right. If I just return person.name.firstname equals DSA, and then just call isValidPerson on P, it'll compile just fine.
Ooh.
But when we run it, we'll get a nice exception. Eventually. Or not. because I did. See, that's actually another important note. This is never being executed because remember how even in linked objects it's deferred.
Yep.
Remember that, Zach?
Mm-hmm.
How the .where isn't actually called until we do a for each or something.
Right, right.
So I'm going to do a top 2 list to force it to run, and now we'll get our exception. Boolean is valid person. If you view details, it should be more explicit, or not. It's really unhelpful. But whenever you see something,
well, it was in the HQL generate expression.
Yeah. But yeah, so we get a not supported exception on this method because linked in Hibernate has no idea how to turn this into SQL.
Right.
Because it can't jump up there into that other method and start, digging. That's not code that's stored in a data structure.
Right. So I mean, that expression can be a block of code, but it needs to be the literal code, and not a reference to other code.
Right.
For the most part, but for example, I'm going to do like the starts with. So this is a method that's available on string, and I'm going to run this. I'm going to open up the NHibernate profiler. And you'll notice it ran just fine, and look at the SQL it generated. It was actually able to, it has built-in knowledge of a lot of the basic type manipulation and comparisons. So you'll see that .starts with is a string method. It's not, obviously it's not literal code, it's an actual method, but linked in Hibernate sees that starts with method and knows how to turn that into...
how to translate that into SQL.
Exactly. And there's a lot of other instances where that's the case as well.
Cool.
So is there anything cool you think we can do with this, Jason?
I mean, you've already been doing queries and pulling information back out of the database.
I'm trying to think of an awesome example.
It's hard for me to come up with an example for you without seeing some sort of a physical interface with which to play with the data, but that's just because that's where my brain lives.
Well, I mean, we could do other weird things like there's the linked in Hibernate provider is really powerful. We can do like p.addresses.any a address dot line 1 equals something.
Well, here's a random question. Can you use these queries to help edit a database? Like, let's say you wanted to get rid of delete out everybody in the database who had a last name of something or had an address of this. I mean, I'm just random example. You can't do that?
Nope. And conceptually, it makes perfect sense if you think about it from a DDD perspective. When we're querying, we're not asking for a completely hydrated object graph that we can use to enforce business logic. We're asking for a single snapshot or sort of a view. And that's not something that we want to be able to edit. And I'm sure they could have, the NHibernate creators could have made it to where I could delete this, but they didn't.
It's just one random question that came to mind.
Well, yeah, it's a good question, but you won't get an error, by the way. The first time I discovered this, I probably sat there trying to figure it out for like 30 minutes before I finally read the documentation. But it'll just not do anything.
Gotcha.
Typical.
I thought that's just what everybody did. It's like you sit there and pine over it for, hour or so, and then you're like, all right, fine, I'll read the instructions.
But you see you can do some really funky stuff with this.
Yeah.
So we're doing .where if any of the person's addresses has a line 1 of 34.
Yeah, and then you send that over to a list.
And it understands this. It generates a little subquery in there.
That's killer. And that's actually a lot easier to write out than SQL. It's like, I hate SQL. Oh, yeah. I've seen SQL, and SQL scares me. But, like, this Lambda stuff is awesome.
Projections. Projections are important. Very, very, very important. Let's say a person had a bunch of fields on him, and those fields contained a lot of data, and we didn't want to return all of that data. We only wanted some piece of it. Let's say the person has a biography field on him, and every single time we retrieve a person, we don't want to retrieve that biography.
Sure.
We can project this person onto an anonymous type, like this. And I know we haven't really, yeah, I know that's redundant, but I'll leave it there. I know we haven't really talked about anonymous types. I mean, maybe we did a little bit.
I mean, the name rings a bell. I feel like we kind of discussed them up to a point. But... And
well,
go ahead, please.
We're basically projecting this into a class that's generated for us by the C# compiler that just contains a name property.
Right.
And then we can loop over it. And we will see that.
So that first query, the people variable, is going to take a query, basically run through everybody in our database and just store out their name?
Yes.
Okay.
So when we loop through person and do control dot, we don't get the age property like we would normally. We just get the name property. And we can do like first name. And then we can run this. And then look at the SQL it generates. And you should do this definitely a lot when you're working with NHibernate, especially... I don't know if anyone saw that, but that was all the names. But you should do this a lot. Even if it's just the trial, check out the NHibernate profiler so you can get a handle on what it's doing behind the scenes.
This probably is a ridiculously simple question, but you know, I mean, can you chain the two together so that you could run a where that took an expression? Oh, yeah. So you know, maybe you sort by address and then use your select from there. Okay. I mean, I figured you could. It made logical sense, but. Just thought I'd throw that out too.
Actually, I'm gonna go ahead and do this. Do some Fluent magic. Remember the relationship between the Fluent syntax and other stuff, Zach?
Yeah, sort of.
Where basically the C# compiler takes this Fluent syntax and flattens it into a basically equivalent to what we had before. And we're getting an error. And the reason we're getting an error is because ambiguous invocation. What it doesn't like. It really doesn't like that anonymous type. Oh yeah, because I'm... There we go. And then we can also do like an order by. I don't think we talked about that, but it's pretty self-evident.
Yeah. Sorting, basically.
Yeah. And we can run this.
There you go.
And we get two people. And look at the SQL it generates. It's really smart about the SQL that it generates because you'll see that it only selects the first name and the last name. Remember, name is a component. It's a value object that contains those two properties. So it only selects this out of the database, and then it also applies the order by, and then it also does the where. So, I mean, that's
cool. That's really cool.
Yeah, it's cool stuff.
Especially when the query itself is so much more elegant and easier to read than the actual SQL that gets written.
Oh, yeah. And if we wanted to do, like, pagination...
I love that word.
This is a really common request. I just want to throw this out here. I mean, pagination, for anyone who doesn't know, is the ability to break things up by pages. We're going to be using that a lot in the ASP.NET stuff. Current var count people dot count. I'm just going to do that. That's whatever. Current equals 0, current plus equals, we're going to do 2 per page. Or, hold on, what am I doing? I forgot how to write for statements. Forgot how to do Boolean logic. This is probably that C++ code I wrote earlier.
It's probably just hanging out with me.
And then we're going to do people.skip current.take 2 because we're doing 2 per page. I'm actually going to break this out into a variable. There we go. Cool. So that's a really simple pagination example. And we'll see that it works.
Oh, nice.
So we're getting 2 items per page.
Yeah.
Except for the first one, because that doesn't work. Or they're probably blank name.
Yeah.
And then look at the SQL generates. Obviously, this is going to be horribly inefficient for what we're doing. But when we're doing when we're doing this in like an ASP.NET application where we hit this query once per request, but we only want to pull out the records that we need based off the current page, you'll see that 1 query was executed per page, and the SQL is actually intelligent enough to add this limit clause, so the database is only returning exactly what it needs to.
Nice.
So that's just another example of how intelligent the NHibernate.LINQ provider is. And then, of course, NHibernate profiler is telling me that I'm an idiot. Select n+1, yeah.
Always nice to have someone help you with that.
Well, I mean, obviously I'm being an idiot because I'm pulling out all the pages in the same
Sure.
request, but we wouldn't do that in normal code. So...
Cool.
Awesome.
I mean,
Is there
it's a good foundation to start with,
Yeah.
so that as we begin creating things in MVC 3, we can make use of NHibernate for querying our data.
Absolutely.
Yep. I mean, we can do joins, we can do group bys, we can do a lot of fun stuff, and it'll all translate into SQL for us, as long as we're working with an IQueryable.
Awesome. Well, I think, again, like I said, this gives us a good foundation to start with. So anything else you want to add in, Nelson?
Do we want to talk about traversing this association real fast?
If you'd like.
Just because I know that we set this association up earlier, but we haven't talked about actually how to get it
Okay.
back. Let's just keep this how it is, and then we're going to loop over all these people, and we're going to grab out their addresses. It's actually sort of semi-complete our example.
Ah, I see what you're saying, yeah. I thought it was better as peon, but you'd have to go rename everything. I thought you really should have refactored it person to peon.
I don't know how people lived before widescreens.
They cried a lot.
Oh, yeah, I'm going to remove this projection. I'm just going to select the entire person
Oh, okay.
so we can get his addresses. Flag for the win. I'm just going to print out one field out of the address just to prove we're getting it. Just line 1. We find. So, yeah. It's going to be pretty cool. It's kind of like the entire effort is
Yeah.
boiled down to this one query.
Nice.
So we get all that. But this is actually bad.
Yeah, okay. Why? Why is it bad?
It's bad, and the profiler will tell us why. And any person who writes SQL will tell us why. Look at this. We start with selecting all the people, which is cool, one query. But look at this. Every single person, we're pulling out all of their addresses. Every single person, we're performing another search.
Like another hit to the database?
Yep.
Yeah.
And any DBA will say, oh, this is why you don't use ORMs. But if you're smart about it, you can do this.
I mean, can you like store it into something like an IQueryable?
No, use a magical method called fetch.
Ah.
So we're now fetching all the addresses, and then check out the SQL that's generated now.
Tell me it's just one. Nice.
It does a left outer join on people to addresses. Now it's important to know, real quick, you can only do fetch on one thing.
Okay.
You can only fetch one association if it's a collection association, because otherwise you'll get what's called the Cartesian product, which is it's basically bad, and you'll get a bunch of repeated data, and it'll be ugly, and Hibernate won't warn you. Another quick note is this will fail miserably for some stupid reason. I don't know why this. I just want to point out this quick pitfall that had me really upset. So we're fetching, and then we're doing a .where, and according to C#, everything's great until we try to run it, and then we'll get some weird ambiguous exception. Yep. And then our weird and ambiguous exception is specified method is not supported.
Mm-hmm.
What we have to do is we have to do the fetch as the last thing.
Okay.
So we have to do that, and that will work as expected. One quick note, but then you'll be like, well, how do I use first or default or single? Because remember, first or default returns... First or default returns the first element that matches this, or null if there aren't any.
Mm-hmm.
Now we can't use fetch, but if we do it like this, we'll get that same exception that we just got, the unsupported method. So to actually work around this, we can be a little bit clever. We can, instead of doing first or default, we can do where, and then we can do fetch, and then singular default. And then we'll get a compiler error, because, well, we're no longer doing stuff and things. And now we don't get an error. Or we do get an error. Hold on. Yeah, I did it backwards. It's .fetch, .toList, .singular default.
Okay.
We have to flatten it out.
Right.
After.
Fetch is still the last thing. We just have to flatten it out when we're done. I mean, in a way.
Yep, and we get more than one element because singular default's not good. Let's start first or default because we're going to get... Because there's more than one Nelson in here for whatever reason. Normally I only use single when I'm comparing against PKs, or primary keys like the ID column. Okay. So now that works, and we'll see that the SQL that's generated isn't particularly terrible. It's just going to be blank. It's just going to be the same thing.
Yeah.
Where first name is Nelson.
Killer.
So that's just a quick overview on how to traverse associations. Remember, you can only pick up one association. So be careful knowing which association you're picking up from. Otherwise, the first time you access an association, another SQL query will be generated to grab that data out.
Cool.
Okay, awesome. Well, Zach, is there anything else you want to ask or add?
Not right now, no.
All right, cool. Well, Nelson, now that we've taken a look at in Hibernate, if you have no objection when we start up on the next episode of Web Development with ASP.NET, maybe we can start looking at the creation of a web application.
Yeah, that'd be nice.
Yeah, it'd be awesome. All right, ladies and gentlemen, well, thank you very much for tuning in. Nelson, as always, thank you very much for having this little lesson here, and Zach for participating. And that will wrap up this video. Thanks again, guys. Bye.